Hi students, today we are going to continue with the problem on the some applications of trigonometry. A 1.5 meter tall boy is standing at some distance from a 30-meter tall building. So there is a one tall building, it is a 30-meter and he is standing at some distance from it. And angle of elevation from his eye to top of the building is increases from 30 degree to 60 degree as he walked towards the building. So from the 1.5 meter tall boy, let this be the ground, and a boy is standing here and his height is 1.5 meter. Let it be the height 1.5 meter. So from here he is watching the top of the building and it's 1.5 meter height, so it forms a right triangle here. And initially he is watching with 30 degree of angle of elevation, and that angle of elevation was increasing 30 to 60 degree as he walked towards the building. So towards the building, from this point he walked some distance and the angle was increases to 60 degree. This angle is 60 degree. Find the distance he walked towards the building. So we have to find this distance that he walked towards the building, right? So 1.5. So this height will be also 1.5. The boy's height is also added to that building, right? Then this rest will be 28.5, right? So total is 30 meter. This is 1.5 and the rest of the building height is 28.5 meter. So now we want to find this distance. So let me name it as an D, C, B, A. So we need to find a AB. So this distance and distance is also same, right? AB. So we have to find the AB. So boy walked towards A to B. So what I have represented in the figure I have written here. So we have to find a distance AB. So it doesn't forms any right triangle, right? AB side doesn't forms any right triangle, but AC and BC we can include it. So AB will be get from subtracting AC to the BC, right? AC minus BC. So AC forms a one right triangle. Here to the ground it is 90 degree and here it is also 90 degree. So it forms one right triangle, and BC also forms a right triangle. So we have to find an AC and BC. So first let me find a BC that involves a triangle DCB. So in triangle DCB, so this is a triangle and we need to find this side, and we know about this side is a 28.5 meter and we know the angle. So which will be connecting, this side is the opposite and this is adjacent. So opposite and adjacent connects the tan, right? So tan, here the angle is a 60 degree is equal to opposite is a 28.5 divided by adjacent is a PC. That is what we have to find. So what is the tan 60? Tan 60 degree is the square root of 3. Square root of 3 is equal to 28.5 divided by BC. Let me take BC here. So BC is equal to 28.5 divided by square root of 3. Okay, then we have to simplify this, rationalize. So into square root of 3 have to multiply on both numerator and denominator. So 5 into root 3 divided by 3. So 3 table it can be cancelled for 9 times and 0.115, 5 times square root of 3, right? So BC is equal to 9.5 square root of 3. So next we have to find an AC. So AC involves the triangle ACD. It's a right triangle, right? So in triangle ACD, we know this opposite side is 28.5 meter. We have to find the AC and the angle is 30. So this is opposite and adjacent, same the tan, right? So tan 30 degree is equal to opposite is 28.5 divided by AC is adjacent, and we have to find it. So sin 30 is a 1 by square root of 3, right? It's equal to 28.5 divided by AC. Let me bring AC here, it will multiply, and here root 3 will be multiplied. So AC is equal to 28.5 square root of 3. So therefore we need a AB, right? So AB is equal to AC minus BC, and AC is a 28.5 square root of 3 minus, and BC is the value 9.5 root 3. So the square root of 3 is the common, and 28.5 minus 9.5, we will be getting it as a 19, right? So 19 square root of 3. So therefore the boy walked 19 square root of 3 meter. Clear? So here we go for the next problem. A statue 1.6 meter tall stands on the top of a pedestal from a point on the ground. The angle of elevation of the top of the statue is 60 degree, and from the same point the angle of elevation of top of the pedestal is a 45 degree. Find the height of the pedestal. So there is one statue standing in the top of the pedestal. So let me consider this be the pedestal and let it be the ground, and above this there is one statue. I'm drawing as a single line. So this is the double line is a pedestal and single line is the statue. So angle of elevation to top of the statue is 60 degree. This forms an a 60 degree, and while from the same point the angle of elevation of top of pedestal is here. This is the top of the pedestal. To this is a 45 degree. To that it is a 45 degree. Okay, find the height of the pedestal. We have to find this height. We know that the statue is 1.6 meter tall, so this height is a 1.6 meter tall, and we know that angle and two right angles will be formed, right? So let me name it as an A, B, C and D. So ABD is one of the right angle, and ABC is another right angle. Then we can find. So let me consider it as an X. So let height of pedestal we consider it as an AD, right? ADB X meter. That is we have to find. So let me choose the first triangle ABC. In triangle ABC we need this side, right? So let me choose this fully, and this angle 60 degree, and AB will be the common for both the triangles. So let me find AB, then equate, because this AB will involve an X and this big triangle AB also involves an X. So let me find the common side and we will compare. So this adjacent, this to angle 60 is adjacent, and this is opposite. It involves an tan. So tan 60 degree is equal to, the opposite is 1.6 plus X, right? 1.6 plus X divided by AB. Since we have to find a full length, and tan 60 degree is a square root of 3. The square root of 3 is equal to 1.6 plus X divided by AB, and let me take AB here. So AB is equal to 1.6 plus X divided by square root of 3. So next we are going to take the next triangle. It is an ABD. So here also we are going to identify AB, which is the common. So in triangle ABD, the AB is adjacent and X is opposite to the angle 45. The same tan 45 we will apply. So opposite is an X divided by adjacent AB, and tan 45 is a 1. So 1 is equal to X by AB. So we know that AB is equal to X. So here also we obtained an AB. That will be equation 1, that will be equation to AB. So let we compare the both. So from 1 and 2, so X will be equal to 1.6 plus X divided by square root of 3. So let me take the square root of 3 this side. It will become a square root of 3x is equal to 1.6 plus x. If I bring here, it will become a subtraction. Square root of 3x minus x is equal to 1.6. And if you take an x common, and this is square root of 3 minus 1 is equal to 1.6. So x is equal to 1.6 divided by square root of 3 minus 1. We have to rationalize, right? So we are going to multiply with the square root of 3 plus 1 divided by square root of 3 plus 1. So in the top numerator will be getting as a 1.6 into square root of 3 plus 1 divided by a minus b into a plus b, say a square minus b square, right? So we will be getting as a 3 minus 1. So the top will be the same, 1.6 square root of 3 plus 1 divided by 3 minus 1 is the 2, and 2 and 16 can be cancelled for 1.6. 16 is 8 times 1.6 is 0.8. So our answer is 0.8 into square root of 3 plus 1, right? So therefore this is what the x, right? X is the height of the pedestal. So therefore height of pedestal is 0.8 into square root of 3 plus 1 meter. Unit is very important. So here we come for the next problem. The angle of elevation of top of a building from foot of the tower is 30 degrees. There is a two thing, and here is a tower, and another one is the, let it be the ground, and here be the building. Let it be the tower and this be the building. So angle of elevation top of the building from the foot of the tower. So from this foot of the tower, this angle of elevation is 30 degree, right? And angle of elevation of top of the tower, this is the top of the tower, from the foot of the building, the foot of this building is 60 degree. So if the tower is 50 meter high, so this height is an 50 meter, and find the height of the building. So we have to find this height. And here also two triangles. This triangle involves a right angle, and here this triangle involves a right angle here, and this is the common, so we can use this common to find the height of the building. So let me name it as an A, B, C, D. So let height of the building be AD. Clear? So let me consider the triangle ABC, so which have an height of the tower, and we have to find the common side, which is an AB. So in triangle ABC, in triangle ABC, this is opposite to the angle 60, and this is 90 degree, and this side is AB is adjacent. So the tan angle here made is a 60 degree. So tan 60 degree is equal to opposite is a 50 meter divided by the adjacent is the AB. So tan 60 is the square root of 3, 50 divided by AB. This we are going to rewrite as an AB is equal to 50 divided by square root of 3. Clear? So we are going to get a common for one more value for AB, so we are going to equate it. So the next triangle ABD, the same, the 30 degree, and this is opposite side building. AD is what we have to find, and AB is we know already, right? So tan, the angle made is an 30 degree is equal to opposite is the building AD. It is what we have to find, and we have to substitute the AB for the adjacent. So we have to find value we know the AB, then we have to substitute that. So the tan 30 is a 1 by square root of 3. 1 by square root of 3 is equal to AD divided by AB. Let me take AB here, it will become multiplication. So AB by square root of 3 is equal to AD. Substitute here in the AB. So AB is equal to 50 divided by square root of 3 into square root of 3 is equal to 80. This we get from first equation, right? We substitute the value of AB here. So we got a AD value. So 3 into 3 is a, square root of 3 into square root of 3 is a 3. So 50 divided by 3 is equal to 80. This is the height of the building. Even this is improper, right? We can write in the mixed fraction like 16 2 by 3. So therefore height of the building is 16 2 divided by 3 meter. So this is written in the improper fraction.